Okay, a little bit more about projections. Here I have vector V, vector W, and the projection line from V to W, and the vector projection. Okay, then maybe I'll draw that vector projection in a different color to emphasize it. And the comment I need to make is simply that this projection is equal to the magnitude of V cosine theta, which is the scalar projection, and which is going to be either positive or negative, depending whether theta is acute or obtuse. And then that multiplied by the unit vector, W, divided by the magnitude of W. Okay. So the vector projection, scalar projection. And also, just to remind you, magnitude of V cosine theta equals U dot, magnitude of is V dot W over magnitude of W. Since V dot W is magnitude of V, magnitude of W, times the cosine of theta. We need to understand all these relationships. Now, another thing about the projection down here, I've depicted a vector U that projects, and these vectors are somewhere in space, no orientation specified here, but the vector U projects onto the vector V here. So here's the projection onto V of U, and it projects onto the vector W here. So if I add these two projections, and I can do that, just do the rectangle, and here is the sum of the projections. This vector plus this vector is this vector down here in the plane of V and W, right? Because if I add a vector in the direction of V to a vector in the direction of of W, and I'm getting my letters mixed up. If I add a vector in the direction of V to a vector in the direction of W, that vector is going to be in the plane defined by V and W. So that this vector V projects at a right angle also to this vector, and in fact to any vector in the plane. So I'm going to say that U is, I said U projects to any vector. U is orthogonal to any vector in the plane, okay? U projects to the vector, we'll call it anything. Projection V of U plus projection onto W of U in the plane of V and W. Now that's an important picture. We're projecting a vector into a subspace, okay? We can similarly project a vector into a subspace spanned by any number of vectors, just by adding the projections onto a set of vectors that span the space. And this is much related to what we do when we project the B vector in our project onto the column space of our matrix. So whether we have a picture that looks like this with our column space here and our null space here, and we have our B vector. We project that B vector orthogonally into the column space by projecting it parallel to some vector in the null space. Okay, this is kind of a picture of the way that might work out in a certain number of dimensions. This projection vector here, the projection from here down into the space would be your vector parallel to the null space. And I don't want to go any further with that, but want to understand this picture and this picture.